What is
Hi, we are Group E, and our project is on continuous integration and development using Azure DevOps.
what is CI/CD? CI/CD stands for Continuous Integration and Continuous Delivery and Deployment. CI/CD starts by integrating code from developers and building and testing the code. This process is customizable and can be triggered off of commits to a repository. Builds can be configured to run tests, check dependencies, and create artifacts. Continuous delivery and deployment is the deployment of project artifacts to test and production servers. Code is automatically deployed for test when a build successfully completes. Why use CI/CD? Without CI/CD, the process has a chance of missing tests. There are environment configuration problems, and time associated with the process is large. Continuous integration builds, runs tests, and deploys the product to avoid test scripts not being run. Continuous integration provides a consistent environment to avoid errors due to differences in machine configuration. Continuous integration provides fast feedback directly to the development and quality assurance. Continuous deployment deploys the project to test and production server as needed when the continuous integration portion of the process has passed. This allows for system usability and user testing, as well as others before deploying a system to production. The project is motivated by efficiency in the build process and improving the quality of code while decreasing the required build, test, and deployment time. By using CI/CD, fast feedback informs the developer of bugs and problems in changes early in development. This increases quality while reducing cost and time required.
Here are some of the problems we found during our review. We identified both functional and non-functional requirements of CI/CD tools. Capabilities required for an adequate implementation of CI/CD software includes automated building, testing, and deployment, integration from code repositories, deployment to different environments, customization of triggers for pipelines, reliable and usable build pipelines, and a fast feedback. Here are the use case diagrams. A user can set the build and test functions of a pipeline through a YAML file. The user can also set up packaging and delivery of artifacts and deployments of artifacts to servers. Azure DevOps is used for CI/CD integration and automating the build process through the use of pipelines. The pipelines are helpful for the reduction in time taken during build, test, and deployment. During the integration, the project must successfully build and also pass a series of tests. Failure to do so results in the pipeline notifying the developers so that they can work towards fixing the issues. A successful build and test results in the project being deployed for the clients to use and provide feedback on. A user, such as the project team, can create build pipelines, deployment environments, and release pipelines.
So in terms of our solution, Azure DevOps is Microsoft's CI/CD management platform. To access it, you need to create an Azure account. There's no installation required. It is all in the cloud and accessed through the web interface provided. In terms of how it meets our requirements, Azure DevOps was built for the purpose of automated pipelines. So it does everything well. During the configuration of the pipeline, a user can select a repository and branch to trigger builds from. YAML files are used to configure the build language, test scripts, deployment platform, and process steps. Microsoft Azure, like all major cloud platforms, is very reliable. It's exceedingly rare that a build would fail because of a Microsoft problem. Azure Pipelines triggers work quickly and effectively to provide feedback as well. Implementing our test design, we use Azure DevOps and a custom API that we created to set up a DevOps pipeline. Adding Azure DevOps and the Azure Pipeline YAML file to our GitHub repository provides the initial setup of the project for CI/CD. The initial functionality provides simple building of the app for Linux. This step does not run the test scripts or deploy the project, however. Our test scripts use the jest library written to run tests in JavaScript and TypeScript. With the addition of the tests to our project, the YAML file is modified to run the tests as well. Now the build pipeline will stop if any of the tests fail. Feedback is provided to developers on both successful and unsuccessful builds. The next step in our test design for Azure DevOps and our API is deployment. Setting up our API on Azure App Service is a quick deployment process which allows successful builds to update the API app. Using YAML, we can specify the web app to update if the build succeeds. The next step to demonstrate the capabilities of Azure DevOps and CI/CD pipeline implementation is the setup of deployment to a production system.
Testing Azure DevOps capabilities. With the setup of the pipeline, the testing of the pipeline can be done showing a failed build, a failed test, successful test and successful deployment, as well as deployment to a production server. These tests of the pipeline rely on the API being able to fail or pass the steps of the pipeline. By adding syntax errors or tests that fail, these conditions can be demonstrated to show the functionality of Azure DevOps and the CI/CD pipeline. The images on the slide are the various results from our tests. The pipeline setup and testing was successful in demonstrating the capabilities of Azure DevOps and CI/CD software. It demonstrates the setup of the pipeline with the repository and YAML file, modification for running the tests, deployment to a server, feedback on pipeline execution result, and a reliable pipeline trigger and execution. The video link demonstrates the setup of and testing of the pipeline from Azure DevOps with the API. The building of the project, test files, deployment, and build results with successful and unsuccessful runs of each step. All right, so here we have our Azure DevOps pipelines. We're going to select our mini API build pipeline, and when we go in it, we can look at the failed builds, the successful builds, and the last builds, and we can also look at our YAML file that we have here as well. So we're triggering it from the master branch, and we're building it for Ubuntu, and we're just doing an npm install and an npm build. And so we're going to add just a failed build, and we'll look at this commit. It says failing build, and when we look at it and run it, and the npm install and build is going to fail. So this is our failing build, and it shows that if the build fails, the pipeline stops there and nothing else happens. So we have a successful build and a failing test, and so when we run this, we'll notice good to go. And then when we add tests, we'll update our YAML file, and when we run it again, we'll notice that it passes the npm build and install, but it fails the npm test. It expects to get a 4, but it received a 5 instead. And so when we add passing test, we'll notice that the command line passes and our build pipeline succeeds now. And we can also look at code coverage and other analytics processes and just get a good idea of where we are for that. Okay, so here's our Azure DevOps continuous delivery. What we have here is our API, and we are using Visual Studio Code, and we are using Azure for Students, and it's just a plugin. And we can publish our app here. And what we're doing is we're creating a name, we're selecting our runtime for a Linux app. It's a Node app, so we're going to be using Node 12.9 since that's the version we're using. And we'll notice that it's deploying in the top left-hand corner, and when it's done, you'll be able to see what the files are, you'll be able to use it, you'll be able to access the API. And so it takes a little while to deploy, but then we can, once we've set it up, we can deploy it to Azure's web service. And once we've deployed it, what we can do is we can add that to the YAML file, and when we add it to the YAML file, we're just specifying a location to add it to our build pipeline. And so this is similar to what it will look like, a build stage and a deploy stage. And we can just use this stage deploy. So it just separates out your build pipeline. It makes it a little clearer what the steps are, where the steps have failed, and it will deploy the Azure Web App directly for you once the build pipeline has passed the tests and the build. And so when we deploy it, it does the build stage, and we can attempt to access our API, but as it's deploying, it won't work at the moment. But we have our build stage and our deploy stage. And once that all passes, we'll notice that the build has published the pipeline artifact and that it has deployed properly as well. And it was just triggered off of this YAML update that we did to deploy it to our test server. And now we'll work on continuous deployment. So this is deploying it after we've passed the tests, deployed it to a test server. This is us deploying it to release or production. So in the pipeline tab, we'll notice releases on the left-hand side. And when we click on releases, we can create a new release pipeline. So we can select a template for a release pipeline, and we're just going to be using Azure App Service deployment, and that's where we deployed our API, just in that continuous delivery step. So we can apply this feature, and then we can set the stage name and stage owner, and we are going to specify where our artifact is coming from. So ENSE 475 is just the sort of company project that we've been working on, and we're going to be using our mini API build pipeline, and we'll be using the latest version. So once we've set that up, we can select our continuous deployment trigger, and we can say enabling it creates a new release on every build. So that would be if you wanted to separate out your continuous delivery portion, and you can just sort of select where you're deploying this artifact to. So we're just going to be setting up another web app on Linux, and we're going to select our mini API, and this is our production instance that we set up, and we are going to say this is a manual trigger only, and this is just because when you're deploying to production, you want just to be able to specify, and you can add approval, and you can say who the approvers are if you have a main point of approval in a team for releases, and you can add extra steps to say the person who wants to deploy it can't be the person who approves it. It's just extra safety factor. And so you can do release triggers as well. You can do a lot of different things for your release pipeline. And so once we've set this up, we can deploy to production. We have our artifact set up, and we are going to save this. And we can say we have manually triggered this release pipeline. It'll tell you which artifact it's using, so you know what it's trying to deploy, and it'll tell you the status of it. So it is not deployed yet, and it'll tell you what the commits are. Because we haven't deployed, it's all of them. And it'll tell you work items if you're using like a Kanban board or sort of agile development methods. And so then you can approve the deployment, and so we say, yes, we're going to approve this, and then it is queued to deployment, and it is in progress. So it's downloading the artifact, and it is deploying it to Azure App Service. And it takes a little while, and then it finishes, and you have deployed to production. So this is your continuous deployment step. It's your last step. You can have extra sort of steps to make sure that you don't deploy accidentally. All right, and that is our implementation of Azure DevOps CI/CD through our API. If there are any questions or any clarification, just let us know, and we can answer some questions. Here are our image references and our project references as well. Thanks for listening.